Thank you guys once again for waiting for this continuation video. Let us go back to the steam plant. This is the continuation. Remember that at first, you can come closer, sir. At first, remember that we did the economizer, the evaporator, and the superheater, explaining. If you only seen this video now, just go back and check the first steam plant. This is the continuation of it. Remember, on the first one, we were explaining how you can get H4 using the first condition. We say that in first condition, you can use the pressure of the plant, which is 2000, and the T-soup, which is, we assume that we can have 2000 and 250. And we say that you have to go to the superheater table, which is here, and you go to 2000. There is your 2000 here. There it is your 2000. I love to take ruler for accuracy. There is 2000, and you come here, you check for 250. There is your 250. You're gonna come here. Therefore, this tells you that your H4 is what? 2904. It is the one that we get here. Can you see it all? We take 200 and you take 250, then it meet us here. Don't write like this in your book. I was just helping you here. Okay, thank you. Let's continue. So this is how you're gonna get everything out of it. So we say that we're gonna have what? 1, 2, 3, 4. Now let us find heat using this enthalpies. Let us start here. Let us find heat of economizer. I will try to be as fast as I can, because remember that when this steam goes out, we are simply going to have what? Mass of a steam here. So when we find the heat of economizer, we say the formula is what? Mass of steam, open brackets, H2, which is this one here, H2 minus H1, which our H1 is here, divided by what? MF. This is going to help us to find what? The heat of economizer. So to find the heat of evaporator, we say that mass of steam into H3 and H2, which is H3 and H2, divided by MF. Remember, MF is mass of fuel, MS is mass of steam. To find the heat of superheater, we say that mass of steam into H4 minus H3 all into MF. Okay, this is how you're gonna get your what? Your heat. Then we can say that you can find what? The thermal efficiency of the whole plant, which the thermal efficiency of the whole plant, when I say 1 to 4, meaning that you started from 1 to 4. This is going to be what? Mass of steam into, remember here we were just doing that H4, H2, H3, H2, H2, H1. But here we are going to say what? H4 minus H1 divided by MF multiplied by CV, which our CV will be given, which is the calorific value that I've explained, a heat value that I've explained here, remember, from video number 1. Then we multiply it by what? 100%, because we are looking for efficiency. You're going to substitute everything, then this is going to help you to get what? Your efficiency. Remember that plant are run in an equivalent evaporation, right? Especially here in evaporation. So it is sometimes can come in an exam that says calculate the EE, or equivalent evaporation, which our equivalent evaporation equals to what? Mass of steam into H4 minus H1 all into mass of fuel multiplied by 2257 at 100 degrees Celsius, right? So this is our EE, is our equivalent evaporation. This is the formula for it. So we are done. I told you that we're going to concentrate on what? Enthalpy and flue gases. So by this way, we are done with what? Enthalpies. Okay, another point that I can raise to you is this. Remember that here on efficiency, if you got the efficiency and you take heat of evaporator, you take heat of superheater, you add with it heat of you actually add all these three heat, and you add the heat of economizer. Then you divide everything by CV, right? You divide everything by CV and you multiply by 100%. You're going to get this efficiency. This is another way of getting efficiency. If you are given all the heat and a CV, and you add this and you divide by CV, then you multiply by 100%, you still can get the efficiency of the plant. I hope this is going to help you someday. Okay, let us still redraw. I just want to show you. Now we are going to flue gases. Remember I said enthalpy, we are done. Now let's explain flue gases. So it means we're going to have what? Economizer. We're going to have what? Evaporator. You must make use of this because you always have to draw it so that you can understand your values. Okay, now I want to explain something here, which is air preheater, and a chimney. Okay, sometimes when we are looking at electrical, where they produce electricity, there are some big things like you see them with this shape, and they are taking out a smoke on top. Those things we call them chimneys. The function of a chimney is to control the air pollution, control that the steam does not cause what? Air pollution. So that is the purpose of chimney. So I said, remember here that we are having 5 components, and the other component is air preheater and chimney. So I've explained already what a chimney is to you. Now let me explain what air preheater is. Okay, if you grow up in rural areas, you know that when you are cooking with fuel, using fuel, at some point, at some time, the fuel will the heat will be reduced of those fuel. If maybe you're using coal or wood, whatever, all those things, in a matter of time, maybe after 1 minute, the fuel will be released, and you find out that maybe you must put in some air, then so that the fuel can burn up again. So the purpose of air preheater, it is done like that. It means that it increases what? The efficiency of the plant, because here we are going to have some coal and they will be burning. At some point they will lose power. So this one, it acts like a fan. It's actually a fan. It means that it takes a TA, I can name it TA1. It means this TA1 is temperature of what? It's a boiler room temperature or atmospheric temperature is T1. It is normally below 40 degrees because it's a normal temperature that we live under. Then let's say it was 25 degrees Celsius, so it will enter through the air preheater, and the air preheater, it got something like a fan, like a rotary. Then it will rotate that air. It means that air will now increase what? In temperature. Then you're going to have what? TA2, and the air will enter through the evaporation and the coal will be burned. Okay guys, good. So on the evaporation, after we burn the coal, there is a smoke that is going to happen. So we actually control the smoke by using it purposely. How? Let me use a blue pen. Where is my blue pen? Let me use a blue pen for fuel gases. So it means that smoke is going to be controlled from evaporator to superheater. Then we name that here we have what? TFG1. When you see FG, you're simply seeing what? Flue gases, right? You simply see what? Flue gases, right? Flue gases. So we're going to have TFG1. It means what is the temperature that left evaporator to what? To superheater. And after the superheater, this temperature, it is, remember there's a steam that is dry that is going into the superheater. So this temperature of the smoke, it is the one that actually convert this wet steam into a dry superheated steam. So it left here, it goes into what? Economizer. So this here we're going to have what? TFG2. We say that we are having what? Temperature of fuel gas 2. It means it left the superheater into the economizer. You must take note that TFG1 is bigger than TFG2. Hallelujah. So it means if maybe here you are given 300, here you will be given what? 250, something like this, because the temperature have been reduced on a superheater. So now you know that there's a feed water that enters the economizer, and that temperature must be increased, so that this steam, it is the one that help to increase that temperature. I hope this now makes sense to you. Then the steam will leave here into the air preheater, passing air preheater. We will have what? TFG3. It means that here on TFG3, TFG2 is going to be bigger than TFG3. It is now making sense to you. So it means, remember there's a temperature from the atmospheric here that enters the air preheater, and then it got increased. For an example, we say let's say we have 25, and it means here we can have what? 100. right? So this temperature, it is increased by the smoke. When the smoke enters in here, it rotates that a roteller or impeller a fan, so that the fan can increase the temperature. So here we are then confirming that on a chimney, on that thing, we are going to have what? TFGB, which we say this is what? Temperature of fuel gas at the chimney base. You now understand it. So this tells you that TFG3 is bigger than TFGB. But you must take note that when the air preheater is not installed, TFG3 is the same as TFGB. When only if the air preheater is not installed, right? So we confirm that here on the we remember that we say that here we are going to have what? The pressure of the plant, which on the first video we assume is what? Is 2000. Then here it means we are also going to have what? A pressure on a chimney, which I like to name it PB, meaning that it is the pressure on the chimney. Then this pressure, let's assume, is going to be 100. Then we say that if this pressure is going to be 100, the process that is happening here, we say it's what? Is a dry fuel gases. So if we need to find the heat of a dry fuel gases, we are going to do like this. Look, we are going to say that heat of dry, alright, it means, remember the dry is here on the chimney, but I'm writing the equation here. Then I say mass of fuel gas, right? Cp of fuel gas, right? Into T what? TFG base minus TA1. Do you see the formula? Did you get the formula? Mass of a fuel gas. Where do we get the mass of a fuel gas? Now that is the question. A formula for mass of a fuel gas is what? Is mass of air plus 1. 1 means that one combustion in a plant happened, right? Then minus mass of moisture. Right? So we have this formula, and it's very important. Now ask yourself, where did we get the mass of air? Mass of air, we get it from where? From the air preheater. Meaning that if we are given the ratio of 18:1, we take this 18 and we put it in an account here that is 18 plus 1 minus mass of moisture. Mass of moisture, it always runs at the level between 0 to 0,9. It's always there. That's why when you are not given, you put it 0. When you're not given, you do what? You put it 0. Now let's go and find what the heat that is going to happen on a air preheater. Air preheater is good. It means it's going to be what? Mass of air, Cp air. Remember that the Cp here is not the same as Cp here. I'm speaking about specific heat capacity. Here's going to be the specific heat capacity of air, specific heat capacity of what? Fuel gas. And we also going to have a specific heat capacity of soup here. Remember that, right? Good. Then here it means we are going to have what? TA2 minus TA1. Because we are on air, it's this one. It's mass of air, CPA, TA, then you minus this one with this one. Come back to the formula. It's mass of air, CPA, TA2, TA1. Right? Did you get that? Wonderful. So now let's go back to this formula. Remember that you now know how to get this. You know how to get this. What about mass of moisture? The formula for mass of moisture, it means it will come from what? The heat of moisture. So to find heat of moisture, I like to dominate it with M. I say it's what? It's mass of moisture into HSS minus HW. Now, you see that mass of moisture, you know it, you can get it from here. This heat, yeah, it's new from you. And what about this HSS? Where do we get this HSS? Let's go back to the chimney base. To get HSS, you have to get it from the chimney base. It is the same as a superheater here, but this one is slightly different. It means you are going to use the pressure on a chimney base and the temperature, meaning you're going to have Hg plus Cp into T soup, right, minus Ts. It is the same. Someone can say TSS, it is still fine, right? Then it means it is the same with when you want to find it on a superheater. So that is the formula to find your HSS. You use the pressure that you are given here and the temperature of a TFG of a base. Then it's gonna help you to get what? Your HSS. Right, Bagiti? Good. So, something that is unfamiliar now is HW. How to get a HW? HW is a heat of water. We know that. Okay, let's take here. Remember that dam was here, right? It is the heat of water. The heat of water, the formula for HW is this. We say that we are taking the Cp of W, which we know that the constant formula for CPW is 4,187, which it runs between here, right? So they will give you this formula, this value, don't worry. Then here it means you are using what? TA1. So you now have what? The formula for heat of water. Do you see it? Good. So then you can substitute it here. Then you get what? The dry of moisture. So this is the dry heat of what? Moisture. This is its formula. Let us go back. We explained everything here. Now we come back and say that how can I get the heat of economizer using flue gas? Remember that in the first video we tell you that you can get what? The heat of economizer using enthalpies. Remember this formula? Now we are telling you that you still can get the heat of economizer using dry fuel gases. Remember here we say that you're going to work with enthalpy and fuel gases. Wow, power machine is so nice. So we say that how can I get the heat of economizer using what? Dry fuel gases. So you still use the formula. I remember when I was still doing my power machines, I was always using this formula and say that MCP change in temperature. I was just writing it down like this, and I know that when I work with fuel gases, I come to this formula. If that formula, let's take an example of this. Take note of this first formula of dry. You see, you have that mass, you have that Cp, and you have that change in temperatures. You come here, you see, if you're working with dry, you know this is going to be mass of a fuel gases, Cp of fuel gases, then the change in temperatures of what? TFGB and TA. If you are working with air, you know that here is going to be mass of air, Cp of air, and change in temperatures of air. It's a nice framework, isn't it? Good. So we now go into economizer. Then to find economizer, you can still use the same equation that I wrote here. So it means you're now gonna say that heat of what? Economizer equals to mass of what? Fuel gas, Cp of what? Fuel gas, and changing temperature. What is the temperature that is between this? Is TA2 and TA3. Between these two, which one is bigger? The bigger one is this. We wrote it here. So it means this is what? TFG2 minus TFG3. It's a nice way of memorizing this equation. You see, it's easy. Now let us skip evaporator and we go to superheater. How can I get my superheater using a fuel gases? It means heat of superheater equals to mass of fuel gas, Cp of fuel gas. Now what is the temperature between these two? Then it means changing the temperature, changing temperatures. I would like to ask the gentleman who is helping me to take a video about the changing temperatures here. Sir, what is it that is going to be here? Is it, tell me, is it going to be what and what? It's going to be TFG. You can talk, it's fine. You can talk. It's going to be T what?
TFG1
and
TFG2.
Good. You see, the gentleman is doing economics, but he can understand science. Wow, that is good. TFG1 minus TFG2. So we now understand that we can get all these things easily. So overall, I think I'm done and I've covered everything. And if you don't understand anything and you want help with, this is my WhatsApp contact, 071 17 22 349. I'm not using them for call. They are only for WhatsApp, and I'm only helping learners there. You can send an equation, anything that you don't understand, then we're gonna talk it there. And please guys, this is not for phone call, it's only for helping people. Good. Or you can follow me on WhatsApp. My name is Puleng Ananias Mahlong. Yes, like this. You can follow me on Facebook. I'm there. You can messenger me. Then you can send your message in inbox. Then ask me anything related to this, related to power machine, any mechanical studies. You can ask. Then we can help each other there. And yes, so for this 5 minutes, I just want to analyze a equation, some question with you. Can you, gentlemen, put it nicely so they can just pause a video and then you take picture of this thing, then you're gonna work it out with us. Yes, you can take a picture, pause the video, then you check the statement.